Hello, my name is Stephen Moon. I am a Senior Specialist Solutions Architect with Amazon Web Services. And today I'm going to talk to you about some of the analytics services that were announced at reInvent 2018. So I'm going to talk about two different types of services. I'm going to talk about new services, and I'm going to talk about new capabilities and features of existing services. So some of those are going to be Kinesis Data Analytics for Java, Managed Streaming for Kafka, Lake Formation, and Amazon Redshift. So Amazon Kinesis Data Analytics for Java. So what are some of the common most use cases for streaming? So security monitoring, industrial automation, log analytics, you think of security, incident, and event management. Data lakes, it's a big topic of conversation these days. How do I get data into my data lakes? And IoT device monitoring are all common use cases for streaming services. So what does Amazon have to offer you as part of streaming service? We have a portfolio of things. We have Amazon Kinesis Video Streams, which is purpose-built for video. We have Amazon Kinesis Data Streams, which allows customers to build their own ends of streaming applications, either through the producer libraries, a client and producer library, consumer producer library, or the client producer library, or through the SDKs to actually build and manage their own streaming data processes. We also have Amazon Kinesis Firehose, which again, through the SDKs or the producer libraries, allow you to do the same thing, except a lot of the process is managed for you, creating different multiple shards on the streams. And it also allows you to inject those streams into specific AWS services automatically. Some of those being S3 or Redshift or other services as well. Then we have Kinesis Data Analytics, which allows you to build applications on your data streams to be able to do analysis and different things against the data that's in those streams. How does Kinesis Data Analytics work? So it continuously reads, processes, and delivers streaming data in real time. So if your sources are, say, are Kinesis Data Firehose or Kinesis Data Streams, it's going to look at that stream and perform something against that stream in real time as those streams are coming in. And then it's going to output it to some other data analytics tools that you can create alerting, respond in real time, or trigger some other action based on that analytic event. Today, Kinesis Data Analytics Stream has been SQL-based applications, so traditional, so typically non-developers or developers that are doing database development are going to be familiar with the SQL Kinesis Data Analytics. What we now have is Kinesis Data Analytics for Java. So what this does is allow Java-based applications to be written for Kinesis Data Analytics in addition to SQL-based data analytics. So again, it's going to be real-time sub 1 second latency processing. It's going to be fully managed apps, so there's zero overhead, serverless, automatic elasticity. It's going to scale to meet the demands of the analytics. It's easy to use. It's integrated with 8 other AWS services. And again, it's fine-grained billing, so you're only paying for what you use. It's built on the Apache Flink framework. So those of you that are familiar, Flink is a programming model for streaming. Apache Flink is an open source. And so it's a simple programming model to use APIs. It's high performance. It's stateful. So you're able to manage state within your analytics processing, and it has strong integrity. So Java applications, and how do I build a Java application in Kinesis Data Analytics? So I build my Java application in my IDE of choice. So whatever you're used to building it in today, whether that's Eclipse or NetBeans or whatever you're building Java applications in, you use the same application. I upload my code, my jar file, to Kinesis Data Analytics, and then I run my application in a fully managed and elastic service. So common use cases, streaming ETL. If I'm getting data in from different streaming sources, I want to clean, enrich, organize, transform my data prior to loading it in a data lake or a data warehouse. That's a typical machine learning use case. Continuous metric generation. I want to aggregate streams into critical information to send to database or monitoring services. So again, I talk a lot about SIEM, security, incident, and event management, and response analytics. So I want to analyze my stream and respond to some change in the stream in real time so I can drive other events based on things that I'm seeing in that stream. This is a use case of streaming ETL for IoT devices. So think of Internet of Things. I'm streaming data in. My Kinesis Data Analytics, I've got a application written in Java. And then I'm pushing that to DynamoDB to power my mobile applications. And then I've got some kind of output on a customer dashboard and alert in real time. So next I'm going to talk about Amazon Managed Streaming for Kafka, which is another new service announced at reInvent 2018. So what is Kafka? Kafka is a mechanism to stream data high speed, real time. It's an open source project as part of the Apache Foundation, and it's been around for a while now. So use cases are real-time web and log analytics, messaging, transaction and event sourcing, decoupled microservices. So decoupling services is a very big, a very good way to build your application so that things don't affect other things. Issues with one part of your application don't affect other parts of your application. And then streaming ETL, similar to what we talked about with Kinesis Data Analytics. So just a little bit about how Kafka works, and if this looks familiar to you, we'll discuss a little bit about how this fits in, similar to Kinesis. I've got a producer that is producing data, and I've got brokers that are doing something with the data, either replicating that for high availability, and then also data consumers on the other side of that broker that are being able to read it. And all that is managed by a zookeeper. So what are the traditional challenges of operating Apache Kafka? So it's difficult to set up, tricky to scale, and hard to achieve high availability. As part of a POC, not so much, because there's plenty of AMIs and different ways that you can deploy Kafka. But for production scaling, it requires a lot of engineering resources to be able to do that. And so if you look at the bottom, a function of Kafka usage in a lot of companies is really a result of the engineering talent they have at those companies. So a lot of you may not be getting the use of it out or the full capabilities out of Kafka that you may be able to get out of it. And then there's no console, no visible metrics that you're able to use with, rolling your own Kafka implementation. And so we offer a managed service now for managed streaming for Kafka. And so it's fully compatible with Apache Kafka version 1.1, AWS Management Console, and AWS API provisioning, just like other AWS resources. Clusters are set up automatically, provisioned Apache Kafka broker and storage, and you can create and tear down your clusters on demand. So at preview, the cluster lifecycle is going to be fully automated. We're going to have brokers and Apache nodes that auto-heal. The IPs remain intact as brokers go on and offline if that happens, and patches are applied automatically. We'll also, for general availability, we'll add a service level agreement and then version upgrades as well as part of that. Scalability and configurability, you're going to be able to scale your cluster horizontally. I want to add additional brokers that are the same, or I want to vertically scale it by adding larger brokers to the customer. I can define custom configurations. I'll be able to define customer configurations. I'll be able to auto-scale my storage. And I have Apache Kafka 2.x support with semi-automatic upgrades. So it's also deeply integrated with AWS services. It's virtual private cloud for network isolation. It's integrated with KMS for encryption at rest. And you can see the other host of things that it's integrated with. At general availability, we'll have tagging, CloudTrail, CloudFormation, and it'll be offered in all of our regions globally. So from a compatibility standpoint, customer is going to be compatible with supports Kafka partitioning, reassignment tooling, Kafka APIs, admin clients, and all the other third-party tools that most customers are used to using. A few things to note that it's not going to be compatible with are going to be some of the Confluent Control Center and Confluent Auto Data Balancer, Uber U Replicator, for example, and LinkedIn Cruise Control. What does Amazon MSK do for you? So I mentioned before, it makes Kafka accessible to your organization without all of the general engineering talent that goes along with having a large production Kafka implementation. And so, as I mentioned, it's generally a function of the amount of engineering talent as the use that you can get out of it. But because it is a managed service, you're not having to deal with all of the administrative and under the covers, under the hood things that you typically would in a Kafka implementation. Driving best practices through design, default, and automation. So a lot of that is handled by AWS, who implements best practices. Allows developers to focus more on the app development without having to actually manage the Kafka infrastructure. And it's Amazon Managed Services for Kafka is committed to improving and contributing back to the open source Apache Kafka community. So I always get asked is, what is Amazon Managed Kafka in Amazon Kinesis data streams? How do they compare? So at a high level, you can think of streams are synonymous with topics, and shards are synonymous with partitions. They both write from producers, and they're both consumed by data consumers. So Amazon Kinesis Data Streams has the full AWS API experience. Throughput provisioning model, meaning that it's not based on the particular size of an EC2 instances versus where the Amazon MSK is the clustered provisioning model. So performance is based on the size of the EC2 instance, underlying EC2 instance is part of that broker. Amazon Kinesis scales seamlessly, whereas scaling in Kafka in general is not always seamless to clients. And it's got a lot of AWS integrations, which are also coming with Kafka, but Kinesis is a more mature service, and so it's more tightly integrated with other AWS services. One of the things that, if you do have a lot of engineering talent with your particular organization, Amazon Managed Services for Kafka is highly configurable, meaning there's a lot of knobs and buttons that you can tune that you can't necessarily do in Kinesis data streams. Next, I'm going to talk about Amazon Lake Formation. So this is probably the best definition that I've seen for data lake, and everybody's probably read about data lakes in the last several years, and it's a buzzword that's gone around a lot. But this definition, I think, sums data lakes up in a very nice and clean manner. A data lake is a centralized repository that allows you to store all of your structured and unstructured data at scale. And that's really what a data lake is. It's a central repository for all of your data. It doesn't have anything to do, you're able to ingest data in it, but it doesn't have to be from the source. There's a lot of different ways that you can ingest data into a data lake, and we're going to talk a little bit about that as part of this lake formation. So why data lakes? I want to put all of my data in a centrally managed location, all of my relational and non-relational data. I want to be able to scale out to exabytes. Most customers aren't on that scale yet. Most customers are in the terabyte to petabyte scale, but we're starting to see people start crossing that exabyte threshold. I want to have a diverse set of analytics and machine learning tools, which I might want to offer an analytics as a service model where customers can come in and use the analytics that I'm providing, or a customer might want to roll their own analytics through the AWS marketplace, for instance. But I want a central repository where all of that data is managed and available to those customers, to my user community of interest. I want to work on the data without any data movement. And so when a data exists in a data lake, I'm not having to move data around. And there is a cost component to that, but really where is in the fact that when you don't have to move data around and everybody's looking at the same data, the results are going to be the same and they're not going to be skewed. So one data scientist group versus some BI group, they're all going to get the same results based on the same set of underlying data, which is very important. And it's designed for low-cost storage and analytics. And so I'm going to talk about Amazon recommends putting your data lake in S3. And so you can see from the diagram here that a data lake is fed by a variety of sources. So not just device and web and sensors, but also your data warehouse could be a source for a data lake. A data mart could be a source for a data lake. It's not limited to any particular thing. But one of the things that you'll notice is very important part of a data lake is to catalog that. And we'll discuss how lake formation takes care of that cataloging capability so that users can come in and see what's available to them in the lake, are able to search and interact with the catalog to be able to disseminate what's available to them. So any analytic workload, any scale at the lowest possible cost. That's the goal, right? And a data lake is going to be Amazon S3 and typically AWS Glue. So analytics, any of your analytic tools or your machine learning services are going to have access to that data lake. On-premise data can be pushed in that data lake, real-time data movement. There's no limit as to what you can put there. So AWS offers lake formation. So you're going to be able to identify, ingest, clean, and transform data, enforce security policies across multiple services in a single centralized manner, and then gain and manage new insights into that data. So how does it work? First, I ingest and I register my sources of my data. I define the permissions on my data on the table and user permissions. I collaborate with my community, whether that's data stewards or the user community, to create my data catalog and add metadata to my catalog. And then I monitor and audit it from a central location. So register existing data or import new. So Amazon S3 forms the storage layer of lake formation. So when I create a lake formation, I have to register an existing S3 bucket that contains data, or I can ask lake formation to create an S3 bucket for me and import the data into it. Data is stored in your account. You have direct access to it. There's no lock-in to the data. So that data is always only accessible by the customer and to whom the customer gives access. Easily load your data into the lake. And so as I mentioned, there's a variety of sources that are going to feed your data lake. Those could be traditional RDBMSs. They could be NoSQL databases such as DynamoDB. They could be Kinesis data streams. They could be really anything. There's no limit to what you can put into it. What AWS provides is blueprints to do either one-time loads of your data, but also incremental loads. So think in the terms of change data capture of your data as well. And so we've got blueprints for a lot of our RDS services, so MySQL, MS SQL, Postgres and Oracle, Aurora. So the customers can actually deploy those blueprints to those data sources that allows them to ingest that data automatically. So with blueprints, you're able to discover the source table schemas. You're able to automatically convert to the target data format, automatically partition the data based on the partitioning scheme, keep track of the data that was already processed, and you can customize any of the templates of any of the blueprints. So one of the features that Lake Formation offers capabilities is to cleanse and associate your data with machine learning transformations. So what we've done is we've taken a lot of machine learning algorithms that cleanse and, so for instance, deduplicate data across multiple data sets, and also create associations between data. So if you had, for instance, a customer that existed in 10 different data sets, we have machine learning algorithms that we've developed to be able to go and look at those data sets and make a determination with a high degree of accuracy that these individual customers are the same customer across multiple data sets. And so we'll continue to enhance and deploy new algorithms and capabilities to Lake Formation, with the intent being to take a lot of that processing and a lot of that logic off of the customer and automate it through our machine learning algorithms. So from a security perspective, and especially for a lot of our federal and other customers that have a lot of security requirements, one of the really great features about having Lake Formation is you secure once. You secure it in one place. I just secure my S3 bucket, but I can access it in multiple ways. So what I'm actually doing is I'm decoupling the security of the data from the application itself. So I set up a user in a Lake Formation, and then a user tries to access that data via one of the services. So you could think of Redshift or EMR, one of our services that's allowed to access it. That service sends the credentials to Lake Formation, and then Lake Formation returns temporary credentials allowing data access. And so the important thing is all of that access is actually managed from Lake Formation itself. And so I don't have to manage those credentials in each individual service that has access to that. All I have to do is pass a token along or pass the credentials along to be able to access the data. So security permissions in Lake Formation, I can control access with simple grant and revoke permissions. So I can grant user access, but I can also revoke users. So if, say, somebody leaves a company or leaves a particular organization, I can revoke a user's access to that data in one single location, so they don't have to go into multiple applications to revoke the data. I can specify permissions at the table level and the column rather than on buckets and objects. And so you think about, I might have a specific table with specific attributes that some user groups can see and some cannot see, or some should not see. I can granularly define who can see what based on those security policies. I can easily view policies granted to particular users. So think in terms of auditability, think in terms of, the federal side risk management framework, being able to audit, applying security controls. I can do that all in a single location for my data. And I can audit all of the access to my data in one place. So I don't have to go out to each individual tool or each individual user application that actually the user came in through. So I can search and view permissions granted to a user, role, or a group in one place. I can verify those, and I can easily revoke policies that I discussed before from a user if that user leaves, or if I detect and monitoring some type of anomaly in their usage, I can fire off an event to actually revoke that. One of the things I talked about was the data catalog, which is a lot of times overlooked feature of the data lake, but it's extremely important in that a user shouldn't have to go in and query the data to figure out what data is there. Really, that should be stored in a catalog. So I can search and collaborate across multiple users. So I've got a text-based faceted search across all my metadata. So if I'm searching for a customer, I can enter that customer's name, for instance, or that customer's ID, and it will bring back all of the data elements associated with the data objects associated with that customer. I can add attributes to it. So I can add metadata that's not included originally, for data owners, the data stewards, and other properties of the table. And I can add data sensitivity level, column definitions, and other as column properties. So I can actually label the type of data that it is from a security perspective, and then only allow users to have access to that particular data. So I can auditor and monitor in real time. So I can see detailed alerts in the console. I can download audit logs for further analytics. I've talked a lot about security incident and event management. That's a hugely important part of the government security posture. I can, data ingest and catalog notifications also publish to CloudWatch. And so all of this I can pipe to CloudWatch, and then I can monitor it in CloudWatch, set up alerting, set up events and things like that based on that alerting. So AWS Lake Formation pricing, there's no additional charges for Lake Formation itself. I get asked, what does it cost to run this? It actually doesn't cost you anything. You only pay for the underlying services that you use. So if you use S3, you pay for the amount of storage. If you use part of Lake Formation is AWS Glue for the cataloging, ETL, a lot of the processing, you pay for the amount of that service that you use. But there's nothing to really pay for Lake Formation in and of itself. So I'm going to go on and talk about Amazon Redshift and some of the new capabilities that have been announced for Amazon Redshift at reInvent. So what is Redshift? Just to recap, it's a relational data warehouse. It's massively parallel columnar data store that scales at petabytes and is fully managed by AWS. It's got roughly 1,000 terabytes a year starting at 25 cents an hour. And so the important things to take away for that, it's all of your SQL-based analytics can apply to Amazon Redshift. But it scales out to, petabyte scale, and it's a columnar store. So it's built for analytics. It's built for SQL-based analytics. So it's got security built into it. So it's end-to-end encryption. It's integrated with AWS key management services. And it also meets a number of current federal compliance standards. So some of the ones I've listed on there specifically are FedRAMP for the DoD impact level accreditation. It's prescribed by DISA. And so it's important to, from a security perspective, Redshift is a very secure and robust environment for analytics. So typical use cases for Redshift, I mentioned traditional data warehousing. If you're doing, dimensional modeling, so fact and dimension tables or even into Snowflake, it's a perfect solution for those types of data warehousing. Big data analytics, so if I've got structured data and I want to do analytics against that structured data, then again, Redshift is a great tool for that, great service for that. And then software, I mentioned software as a service, analytics as a service. Analytics as a service is a big thing where I might want to manage how users consume analytics. So Amazon Redshift Spectrum in and of itself is not new. Amazon Redshift Spectrum allows you to use S3 as your data source to store data at a much lower price point than you would if you had to store on Redshift nodes. It allows you to access and do analytics. So a lot of times customers will store large fact tables in S3 to reduce the cost, but they made to store their dimensional tables in Amazon Redshift itself. Some of the newer features that are coming is, in particular, is unload to Parquet. And so if you're familiar with ORC or Parquet, these are open source, open data formats that many analytics tools are able to consume. So most of your Hadoop-based ecosystem tools and things like that. So what it does is it allows you to take data and unload that data into S3 in an open format, so there is no lock-in. So any tool that could consume an open format, any of these open formats, particularly Parquet, can use that data just like Redshift can use that data. Elastic Resize, so it'd be able to scale up and down in minutes. So add additional nodes to the Redshift cluster, run queries faster in busy periods. So as my query requirements pick up, I can actually add compute nodes to the cluster, minimizing my transition time, and then scale compute and storage on demand. So again, if my storage is on S3, I might just need compute, but if my storage is in the Redshift cluster itself, I might need to expand storage as well at the same time. Concurrency scaling. So I can also, this is a new feature, I can automatically create more clusters on demand. So if I have a bunch of people coming in and I need to create additional clusters, I can do that without moving the cache layer as well, so that I can create additional Redshift clusters for consistently fast performance across thousands of concurrent queries. I don't have to rehydrate my cache, which I mentioned before is a lot of times when you create a new database, if you have to rehydrate your cache in order for performance to pick up. In this case, you don't have to. And quickly scale to serve changes to the query workload. So Amazon Redshift Intelligent Maintenance, a lot of what AWS is trying to do is take a lot of the O&M away, out of the hands of the users so that you can focus on the business. So things like analyzing workload management, concurrency settings, and vacuum in Redshift are actually being part of our intelligent maintenance feature so that you can move towards a zero maintenance overhead. And as you move through these, you'll see a lot of the what we're trying to do is, again, take the onus off of the customer so that the customer can focus on their business or organization. So Redshift Intelligent Administration. So one of the things when you set up a Redshift cluster is you just have to determine your distribution key, how the data is going to be distributed across the cluster. And that can be challenging to a certain extent. And you might have different situations where different distribution keys might apply based on the query patterns. So you might have multiple tables, the same data with different distribution keys. So what Amazon Intelligent Administration does things like advise you based on access patterns and doing an analysis of your data using some algorithms and machine learning algorithms to recommend a distribution key and then automate data distribution in tables for improved performance. So it's taking the onus again off of the customer for having to manage distribution keys, which is a non-value added activity to your business, and allowing you to do, focus on your queries and your analytics and things that are driving your organizational requirements. Running stored procedures in Amazon Redshift is a new feature as well that's going to be, it's coming soon. And what that's going to allow you to do, just like your typical Postgres database, run your PG-SQL in Postgres, it's going to allow you to run stored procedures in a Redshift database. Lastly, I want to talk about the integration with Amazon Lake Formation. And so Redshift is going to be one of those services that's going to be integrated with integrated with Lake Formation to be able to read data from your data lake and do analysis against that data. With that, I would like to say thank you for watching this video. If you have additional questions about any of the services, new services, features, or capabilities that I've talked about, please reach out to your Amazon account executive or your Amazon solutions architect.